Okay, so second section, we're going to look at 2.2 part 2. Okay, basically, it's continuing on with unit circle trig, except we're going to look at a couple special coordinates. Okay, we're going to look at how do we find the coordinates for those three angles. Okay, so we've got a 30, 45, and a 60. And if you're doing this in radians, we have pi over 6, pi over 4, and pi over 3. As always, if we're working in radians and it's confusing to figure out the coordinate in radians, you can change to degrees. But the goal is ultimately to figure out the coordinate. Whether you want to use radians or degrees, that's up to you. All right, so I'm going to start with seeing if we can figure out the coordinates for a 45-degree angle. Right, so the first thing that I've done is I drew my unit circle. Somebody remind me what's a unit circle again? What does that mean? Okay.
The radius is 1 unit.
Yeah, the radius is 1 unit. Okay. So here's 0 degrees. There's 90 degrees. I just tried to estimate 45 the best I could. It's somewhere between 0 and 90. Okay, exactly halfway between. All right, so when I'm saying I'm trying to figure out the coordinates for a 45-degree angle, this is the angle I'm talking about right there. Okay? Between the positive x-axis and that diagonal line I just drew. Okay, 45-degree angle. Now, some people say that the coordinate for 45 degrees is 1, 1. Does anyone agree with that? Or if you disagree with it, can you tell me why it wouldn't be 1, 1? Jamal?
It's not 1, 1 because it's unclear.
Yeah, if you went right 1, you'd go here, and then up 1, you'd be up there. That's right 1, up 1. So the coordinate is not 1, 1 for 45 degrees. All right, so any thoughts? I want to turn this line segment I just drew into part of a shape. Anyone have an idea what shape I can make out of this? Yeah, I could make a triangle. And how can I make a triangle out of what I have? Where would I need to add a side? Yeah, Jessica? Yeah, let's add a perpendicular line from that point down to the x-axis. Okay, so that looks perpendicular. So that's a 90. So this triangle right here, I'm going to draw it a little bigger off to the side. Right, so that's the triangle I have right now. This angle at the bottom is the 45-degree angle I mentioned earlier. But how do I know the angle at the top is a 45? I didn't say anything about the angle at the top. But it also is 45. Devin? Yeah, if you've got a 45 and a 90 at the bottom, that's 135, and altogether the angles in a triangle have to add up to 180. All right. So this point right here is that point right there. This is my origin. That point corresponds to that point. So my goal is to figure out from the origin how far to the right and how far up do I move. So basically I need to figure out the length of the bottom side and the length of the height. I need to find those two things. Is there any side in this triangle that I already know the length of because it's in a unit circle? Miles? Yeah, I know the hypotenuse because it's the radius in the unit circle. And earlier Gabe said that the radius is 1. Now that doesn't directly give me the coordinate. I really need the bottom side and the height. That's the coordinate. I don't know them right now, but if I were to compare the length of the bottom side to the height of this triangle, how would those compare? if you measured the bottom side and then you measured the height? Thoughts on how they would compare? Think about what kind of triangle do I have there? It's a right triangle, yeah. Can anybody be more specific than a right triangle? Okay. It's an isosceles right triangle. What does it mean if a triangle is isosceles? Becky? It means two sides are the same length. So now if I go back to my question, if I measured the length of the bottom side and I measured the height of the triangle, how would those two sides compare? They would be the same. So I don't know what they are right now, but I know they're the same. So let's represent the bottom side as x. And if it's the same as the height, how could I represent the height? X. You don't want to pick something different because it's not different. It's the same as the bottom. Okay. So whatever the coordinate is, this number that I put here and that number that I put there are the same. I just have to find out what they are. Any thoughts on how I can figure out the length, or how do I find x in that triangle? Something you've done before, maybe not in this class, but you have done it before. Do you know? Yeah, we'll use the Pythagorean theorem and solve for x. All right. So Jamel, can you set that up for me using what I have in that triangle?
X squared plus x squared equals 1 squared.
Perfect. X squared plus x squared equals 1 squared, and yes, 1 squared just comes out to 1. And Gladdy, if I combine my like terms on the left, what do I have there?
2x.
Close, not 2x though. If we had x plus x, that would give me 2x.
X to the 4.
Nope, not quite. How do we combine these terms? Because they're like terms. We just need to combine them. Josh?
2x squared.
Right. You have an x squared plus another x squared, so you have 2 of them. 2 of the x squareds. Okay. David, what would be my next step to get x by itself? Yep, we're going to divide by 2. Divide by 2. Just going to go over here. So x squared is a half. So how would I get x? Yep, Devin.
Take the square root.
Yep, take the square root. And when you take the square root of a fraction, you do the top and the bottom separate. So take the square root of 1. Take the square root of 2. Something there I can simplify nicely. Does anybody see which one of those I can simplify? Well, right? Okay, what's the square root of 2? If you can't answer that, then it's not something we can simplify in our head. You have one other option to pick. The square root of 1. So the square root of 1 would simplify to 1. Right, so that's x, 1 over the square root of 2. The only problem is we generally don't like to leave something with a square root in the bottom. So to fix that, how would I fix that fraction? Jackie?
Square the top and bottom like this.
Can you just say it one more time?
Square root of 2 on the top and bottom.
And what are you going to do with the square root of 2 on the top and the bottom? Are you adding it? Multiplying, perfect. So when you do that, multiply by square root of 2 in the top, you get square root of 2. What if you multiply the bottom by square root of 2? What do you get? 2. And that's x. Right? So now we know the length of this side is square root 2 over 2. and the height is square root 2 over 2. So how would I write my coordinate to get from the origin over and up to that point? What would be my coordinate? You know?
Square root 2 over 2 times square root 2 over 2.
Yeah. We saw that coordinate yesterday. I didn't explain where it came from, but that's the coordinate for 45 degrees. You have to go right square root 2 over 2 and up square root 2 over 2. Okay, and now that we know that's the coordinate, we don't want to have to go through the Pythagorean theorem again to figure that out. That's just something you want to memorize. Square root 2 over 2 is a 45-degree angle. Okay. So any question on how we figured out that coordinate? Now, if I asked you to find the sine, the cosine, or anything else, all you have to do is take this coordinate and plug it in, just like we did yesterday. The only extra step is you just have to know this coordinate now. All right, so let's try doing a problem with that. Okay, I want to find the 6 trig functions of 45 degrees. Okay, if I want the 6 trig functions, what's the first thing I need to figure out in order to answer any of those 6 questions? Yeah? I got to figure out the coordinate for 45 degrees. Okay, we just did that. So if you don't remember it, then you got to figure it out again. Or if you have it memorized, we just write it down and just go with that. So what's the coordinate for 45 degrees? Wendy?
Square root of 2 over 2.
Yeah.
Square root of
And square root of 2 over 2. So we're going to find all 6 trig functions using that coordinate. Okay. Look back. Let me show you something we did yesterday. We've already done this problem. This was example 2 in our notes from yesterday. Find all 6 trig functions using that coordinate. The only difference between the problem today is I didn't give you the coordinate, you figured it out. Yesterday I gave it to you. Okay? But especially for those that weren't here, we'll go through how you do this. First thing, make sure you know which coordinate is x and which one is y. Okay, and then we'll start with sine. Okay, what's the definition of sine? What letter is that equal to? Gabe?
Y.
Yeah, that's the y value. Okay. Kelsey, in this case, what's my y value? Yep, it's the square root of 2 over 2. And that's it. That's all you have to do to find the sine. Marcos, how about the cosine? How do we do that one? Yep, cosine is x, which in this case is also square root 2 over 2. And now the tangent, we looked at this one when we did the homework. James, how do I find the tangent?
It's y over x.
Yeah, it's y over x. So it's y divided by x, but in this case they're the same. So Ariel, what do you get when you divide y by x?
1.
Yeah, you get 1. Now that we've got the 3 trig functions on the left, can someone remind me, what do you do with each one of these to get the 3 on the right? Glad?
Use the reciprocal.
Yeah, just use the reciprocal. That just means take each one and flip it. So Henley, what do I get if I flip root 2 over 2?
It's going to be square root of 2.
Okay, so 2 things she did. One is when you flip it, the root is going to go to the bottom. And then you have to fix the root being in the bottom, so you multiply top and bottom by root 2 over root 2. And then you're going to get 2 root 2 divided by 2, which is what she just said, root 2. Great, so we did that one yesterday. The secant, how about the secant of 45, Jocelyn?
It's the same
Yeah, why? Why is it the same?
because the cosecant is the same. as the sine?
Because the sine and the cosine are the same, yeah. Because those two are the same, the two on the right are the same. And the last one, my cotangent. How about, yeah, Jamel, what's the cotangent? 1. So we did that exact problem yesterday. Okay, any questions on how we did that? Okay, so I want to just try something for a second. I'm not going to focus on this too much today, but that was a 45-degree angle. Okay, it was exactly halfway between 0 and 90. Okay. Well, let's look at the 45-degree angle in the second quadrant. Okay, and this part, you could just watch this part. That's all you have to do. What's exactly halfway between 90 and 180? If you're not sure, you could just add them up and divide by 2. Just take the average. 135. Okay, so 45 is over here. 135, it's basically flipped over on the other side. Here's your triangle for a 45-degree angle. Here's your triangle for 135. How do those triangles compare to each other? I mean, if I drew it perfect, it's not perfect, but there's a relationship between them. Yeah?
They're a mirror
Yeah, they're a mirror image of each other. So if this side is root 2 over 2, then the side on the other side is also what? Just tell me in terms of how long it would be if you measured from here to there. It would also be root 2 over 2, but I'll come back to what you just said in a second. Okay, the height here was root 2 over 2, so the height here would be also root 2 over 2. So when we start to look at 45-degree angles in other quadrants, the only thing that's going to happen is what Jacqueline just said. Same numbers, except one of them becomes negative. So if you wanted to figure out the coordinates for 135, it would be a negative root 2 over 2, positive root 2 over 2. Okay. So we're gonna look more at that tomorrow, but that's all that's going to happen when we draw angles in other quadrants. Any question on that? You can do the same thing. You can put a 45 down here, or you can put a 45 over there. Every one of those coordinates is going to be a root 2 over 2, comma root 2 over 2. It's just sometimes they're both positive. They could both be negative, or you could have one positive, one negative for the x and y value. Okay, but I wanted to kind of tie that in, and that's more of what we're going to look at tomorrow. Okay, for today, we'll stay in quadrant 1. Okay. Any questions on the 45-degree angle? Okay. All right, so the last two angles we're going to look at are 30 and 60, and we're going to look at them together because they're in the same triangle. Okay, so this time I've got my same picture. That's 0. That's 90. That's it. Okay, that's 30 degrees. Just try to make it a little bit less than half. Okay, I'm going to do the same thing I did last time. I'm going to make a triangle by drawing a line from my origin to the point that I estimated was 30 degrees. And then draw a line straight down to the x-axis. Okay, so the angle right near the origin, that's my 30. Okay, it's between the x-axis and the hypotenuse. Okay, based on what we said last time about triangles, what does this angle at the top have to be? Yeah, it's got to be 60. And that's why we're looking at the 30, 60, 90 right triangle. Okay, I've just drawn it a little bit bigger off to the side so we can look at it. All right, so I'm going to try to start off like I did last time. I want to label any side here that I already know the length of. Okay, is there any side that I know the length already? Yeah. The hypotenuse, how long is it? It's 1. It's the radius in the unit circle, so it's 1. Again, that doesn't directly help me, but it will in a little bit. I'm trying to figure out how to get from here to here. Okay? Moving along the x-axis and then up. What kind of triangle is this? Do you know? It's scalene. What does that mean if it's a scalene triangle? Yeah? None of the sides are the same. So I can't do the same trick I did last time. I can't just call one side a letter and the other side the same letter because they're not the same length. One side is shorter, the other side is longer. All right. So if you remember your 30, 60, 90 right triangle, then if you have that memorized, then you can already figure out the answer to this. But let's pretend that you don't have that memorized. Okay? And we probably don't have to pretend. So what can I do to try to figure that out? Do you have any thoughts? It's kind of it's something I'm going to do. It's like visual, like a trick I'm going to do. I'm going to add to this picture a little bit. Well, I'm going to click on that. So I just have this triangle, and I'm going to go like that. That's my first step. Any thoughts what I can do with that? Yeah?
Make that into a rectangle.
Okay, so I could flip this in a way I could make it into a rectangle. But then I'm going to ask you, what do I do with that? We definitely have a rectangle there. There's four right angles. So it's a rectangle. But how would I get the height or the length and the width of it? I don't know either. So I'm gonna change it back to what I had before. I'm just gonna put it like that. Does anybody have any other thought? He's kind of on the right track though, of what I could do with this triangle. Make it a big triangle. Okay. How would I do that? Where do you want to put this?
Flip it.
Flip it? Which way do you want to flip it? Left, right, or up, down?
Left, right.
Up, down, you said?
Yeah.
That's a good idea. And now, where could we put it to make a big triangle?
Flip it again.
No, I like that. I just want to move it now. Yeah? We'll put it to the bottom. So we used your idea. We created a big triangle, just a little different than we thought. Now, look at the big triangle. What kind of triangle is, if you trace on the perimeter, is that? It's equilateral. I have a 60, that's a 60, and the angle at the bottom is a 60. So what's an equilateral triangle? What does that mean? All the sides are equal. So that side's 1, that side's 1. More importantly, this entire side is 1. What else does that tell me?
Half of that side is
Yeah. This side is congruent to that side. All we did was make a mirror image. So if you add these sides together and you get 1, that means each one of them has to be a half. Now we just figured out one of the sides we didn't know. Okay, we don't need the bottom part of the triangle anymore. Okay, so we could keep it, but just to make it simpler, I'm just going to focus on this triangle, and I now know the hypotenuse is 1. The right side, using a little visual trick, is a half. And the bottom side, I still don't know that. So what could I call it since I don't know it? Yeah, we could call it A. But we have 2 out of 3 of the sides, so we can use the Pythagorean theorem. Okay, so let's set that up. A squared plus a half squared equals 1 squared. Okay, I'm going to simplify what's on the left. What's a half squared? Or half times a half? Yep, 1/4. So a squared plus a fourth. 1 squared is just 1. Okay, 2 steps left to get a by itself. What's my next step? Minus a fourth. What's 1 minus a quarter? 3/4. And that's not a, that's a squared. So what would be my last step? Yep, take the square root. And again, with a fraction, you do the top and you do the bottom. This time, what's going to work out nice is you can take the square root of what's in the bottom. What do you get when you do the square root of 4? 2. And the top, you just leave it. So the length of this bottom side is square root 3/2. So now, from the origin, okay, we know how far we have to move to the right, and we know how far we have to move up. We just need to write that as a coordinate. Okay, so what would be the coordinate for 30 degrees? Okay, how about Mercedes? See what the coordinate would be?
The square root of 3/2.
Yep.
Comma 1/2.
Perfect. That's your coordinate for 30 degrees. We know this side is square root 3/2. We know that side is 1/2. Now, from now on, we're just going to write that down. We're not going to go through all the steps to figure that out ever again. Okay, so now we just need to know that's what it is. If you forget it, you can figure it out again, but it kind of slows you down. All right, so that's the coordinates for 30. Now, I want you to put in a 60. Okay, and I'm going to draw that triangle on the same diagram. Now, we don't need to go through all the work again. Does anybody see the connection between the triangle I just drew and the one I had before? Yep, Devin?
You like flip it and then bring it down to the left, it's the same triangle?
Yeah, these are the same triangle. The only difference between it is you've kind of like stood it up on the short side and maybe you flipped it. But it's exactly the same triangle. So using that idea, anybody think they can give me the coordinates for 60 degrees? Knowing that this is exactly the same triangle as what's down below, it's just on a different side. Gladys?
Would be 1/2 and square root of 3/2.
Yes. It's the only difference between the coordinates for 30 and 60. The x and the y switch places. And the way you can remember that, if you, let's go like this. What's 1/2 as a fraction, as a decimal? Yeah, what's 1/2 as a fraction? Do you know? Yeah, 0.5. Okay. Now, if I take the square root of 3 and divide by 2, it's about 0.87. Okay. Square root of 3/2 is a bigger number than 0.5. Well, the bigger side is always across from the bigger angle, and the smallest side is always across from the smallest angle. So that's that's how you can remember which one goes where. Smallest angle, always across from the 1/2, because it's the smallest side. The bigger angle is always across from the bigger number. That's square root 3/2. All right, so now we'll take a look at doing a couple problems with 30 and 60-degree angles. Okay, so I want to find 6 trig functions for pi over 6. Okay, so Wendy, what's the first thing I have to figure out? Yeah, I've got to get the coordinates somehow. I can't do anything until I get that. Now, in the past, some people have suggested doing something with this, and if you want, you can do that. What have we done in the past when we had something like pi over 6? Yeah, we've changed it to degrees, just because a lot of times people can visualize degrees in their head easier than radians. What's pi over 6 as a degree? 30. Okay, so now you either have to know already what 30 is in your head, or if you don't, you can make a sketch. You don't really have to go through all the work again. You just have to remember the 2 numbers, the root 3/2 and the 1/2. You just have to figure out which one goes where. If you draw a sketch and you make it somewhat accurate, watch what happens. Okay? Put 30 degrees closer to 0. Draw your triangle. Just by drawing it, I can clearly see which side is the short side. The height is the short side. The base is the long side. The long side is always which number? The 1/2 or the root 3/2?
1/2.
So 1/2 is a bigger number than root 3/2? Well, Riley? What do you think? Which one of these 2 numbers is bigger? We just did this on the calculator. And I said, write this as a fraction. Remember that little funny thing? Yeah. The root 3/2, that's a bigger number, right? 1/2 is a smaller number. This is 0.5. Root 3/2 is about 0.87. 0.8 is bigger than 0.5. So put the bigger number where the bigger side is. Put the smaller number where the smaller side is. So in this case, what side is the bigger side? The x or the y? Okay? Yeah, the x. So the bigger side is the bigger number. The smaller side is the smaller number. And that's the y in this case. Okay, so the coordinate is root 3/2, 1/2. Okay, so if you mix them up, that's how you do it. Just draw the diagram and look at the sides. But you do have to memorize these 2 numbers. Not necessarily the right order, but you got to know the 2 numbers. Okay, so we'll start with sine. David, what's the sine of pi over 6?
1/2.
Yep, 1/2. And Gladys, the cosine?
Root 3/2.
Root 3/2. And Becky, to find the tangent, that one's a little harder, so can you just tell me how I would do it? Yeah, we're going to take y, and we're going to divide by x. Okay, James, when I divide y by x, what's going to happen?
I don't know.
Well, look at those denominators. How do the 2 denominators compare to each other?
Because they're 2.
They're the same,
Yeah.
right? So when you divide 2 fractions with the same denominator, the denominators,
2.
nope,
Same.
nope,
4.
no. Yes.
What's that?
Cancel.
I hear you.
Can somebody help James with what's going to happen there? They cancel out. So if the 2's cancel out, you're left with, I'll just write it. You've got this. Some people like to take what's in the bottom and flip it and multiply. That's the same thing. You're still going to cancel the 2's if you do it that way. But you're left with 1 divided by the square root of 3. Okay. Numerically, that's correct. The only problem with it is there's a root in the bottom. Can somebody tell me what that would be if you fix it? So there's no root in the bottom? Miles? It would be the square root of 3 over 3. Don't get rid of this other answer that we have. I'm going to come back to that in a second. All right, cosecant. That one's going to be easy because when you flip it, there's no root. It's just a 2. How about my secant final answer? Cleaned up as much as it needs to be. Yep. Perfect. 2 square root 3 over 3. And now the cotangent. We should be able to do that one without really too much work at all based on what we've already done. What would the cotangent be? Yep. Just the square root of 3. So your choices are either take the final answer for tangent and flip it. But if you do that, the root's going to go back to the bottom and you have to fix it all over again. Or take what we had at this step and flip that. It's the same thing. That's why they're equal to each other. If you flip that, the root goes to the top and you're done. Any questions on that one? Okay, so there's your 6 trig functions for a 30. Okay, and take a second and see if you can figure out on your own the 6 trig functions for 60. Okay, if you get stuck, let me know. I'll come around and give you a help. All right, so first thing we got to do is get our coordinate for 60. What 2 numbers does the coordinate involve, even if you're not sure the right order? Yep.
1/2 and square root of 3 over 2.
Yeah, there's a 1/2 and there's a square root of 3 over 2. That's 0, and that's 90. 60 is closer to 90, okay, than it is to 0. So if I make a triangle, I can, even just drawing it really quick, I can see that's the short side, and then I can see that is the long side. How long is the short side? Which number is that? That's always the 1/2. And how about the long side? Yeah. So now I know that x is a 1/2, and the height, the y, is root 3 over 2. Okay, so even if you forget the order, you can always draw that picture and figure that part out. So 1/2, root 3 over 2. And now we'll just go through and find all 6 functions. So Kristen, what's my sine?
Square root of 3 over 2.
Yep, square root of 3 over 2. How about Marcos, my cosine?
1/2.
Yep, 1/2. Okay, and the tangent, I'm going to divide these 2. So James, when I divide these 2 fractions,
That's the square root of 3.
right, because what happened to the 2's?
They cancel.
Yeah, they did. All right, so the 2's cancel and we get just square root of 3. Okay, you could put it over 1 if you want, if you need to put something there when you flip it. But now let's go through the other ones. Gabe, what's the cosecant?
2 square root of 3 over 2.
Yep, so perfect. He flipped it, put the root in the top, did everything all in one step. The secant, we're going to flip that and get 2. Okay, and how about Becky? What do I get when I find the cotangent? Square root 3 over 3. Okay, so I asked you if you noticed any patterns between the last problem and this one. Okay. Which kind of things switched around a little bit? Can anybody give me 2 trig functions that the answers switched places? Like the something and the something switched? Glad?
The tangent and the cotangent switch.
Yep, so we had the tangent switched with the cotangent between this problem and the last one. What else? Jamal?
Semi-constant.
Yep, the sine switched with the cosine between this problem and the last one. And that leaves the secant and the cosecant. Did anybody notice kind of a pattern in the functions that switched? Anybody see the connection between tangent, cotangent, sine, cosine, secant, cosecant? What's the pattern there, though? There's a pattern. Let me say it again. So tangent, cotangent, sine, cosine, secant, cosecant. Nobody sees that pattern? And just how was I pronouncing them? I tried to emphasize how was the co, right? When these functions switch places, they switched with the co of the function. Okay, we call that the co-function. Tangent and cotangent are co-functions because you just put the word co in front of tangent to get the other one. If you put the word co in front of this one, you get cosine. And if you put the word co in front of that one, you get cosecant. Okay? So those pairs of functions that switch places are called co-functions. Right. Any questions on getting the 6 trig functions for 60 degrees? Okay. What if, let's say I asked you for the 6 trig functions of, let's do this, 420 degrees. What should you probably do first? Devin?
Minus 360.
Minus 360. And then you would see it's exactly the same problem we just did. Okay, so if they give you angles bigger or smaller, then bigger than 360, smaller than 0, add or subtract 360, and it's probably going to come out to one of the ones we did today or yesterday. All right, so the homework tonight is going to be a worksheet that has the first 10 questions on it. And then on the board, I put the last 5. Okay, so these 5, you just need to copy those down. The first 10 are on the worksheet. Okay, for each problem, you don't have to do all 6. Okay, especially for the ones that I'm looking at here. In number 11, all I want to know is the cosine. You don't have to give me anything else, just the cosine. And the way they're set up on the worksheet, I'll just show you the first one. Okay, so the first problem on the worksheet says sine 45 degrees. Okay, and there's 2 spots. The first one says coordinate. And the next one says answer. Okay. So what I'm looking for in the coordinate is a coordinate. Okay, I'm looking for what is the coordinate for 45 degrees. Okay, that's the first thing. The answer is once you have the coordinate, tell me the sign. So in this case, you'd be looking for the x value or the y value. The y. So what goes on the answer line is the y value of the coordinate. And that's exactly how it's set up on the test. Coordinate and answer.